Hello guys, welcome back to Chemistry Adult. Today we'll be learning types of formulae in organic chemistry. So the topic today is types of formulae. When you're talking about organic chemistry, there are essentially speaking 5 types of formula that we'll be talking about. The first one is molecular formula. The second one is empirical formula, right? The third one is structural formula. The third one is structural formula. The fourth one is displayed formula. And the fifth one, the one that you would not have encountered as of yet, would be the empirical formula. The skeletal formula. The skeletal formula. Each one of them has their own purpose. They are used for different purposes, different representation of molecules, and of course, we'll be learning the application of each and every one of them. But of course, we must know why and how is each one used. So let's say the first one that we'll do is ethanol. So we have this compound ethanol. Let's see the different types of formulae in it. So ethanol is a compound that has 2 carbons bonded to an alcohol, right? So here is the structure for ethanol. As you can see, we show each and every single one of the bonds inside ethanol, of course. But the thing to note here is, very important thing to note here is that some students forget that this OH bond. This is simply write it as OH without the bond between oxygen and hydrogen. You need to show it in the displayed formula. It's very important. In displayed formula, all bonds between all atoms are shown. So all bonds between all atoms are shown. And this is known as the displayed formula. Right? Next one. The next type of formula is the structural formula or the condensed formula as well. We call it the condensed formula as well. So how do we write it? How do we go about writing it? So the thing you need to notice here is, so we have the structure of ethanol here, right? Now this is a CH3 group, this is a CH2 group, this is an OH group, and they're all bonded to each other, right? So let's write them like this: CH3 bonded with CH2, which is bonded with OH. Now this is a condensed form of the displayed formula, and therefore it is also known as the structural formula or the condensed formula. So let's erase this. So this is structural / condensed formula, and you can call it whatever you like. Third one is the molecular formula. Now in the molecular formula, you just need to count each element and write the number of atoms of that element present in that compound. So for this compound, we have 2 carbons, so C2. Let's count the hydrogens: 1 2 3 4 5 6. There are 6 hydrogens. There's 1 oxygen, right? So 1 oxygen, right? Let's raise these. Now this is known as the molecular formula. It only requires simple counting, right? But here's the thing. So this is the molecular formula. What if you want to write the empirical formula? Now empirical formula is just based on the simplest ratios. It is the simplest ratio of all elements in a compound. Now essentially speaking, for example, if you have a compound, let's just say C4 8602. You divide everything by 2 because that is the smallest number, which will give you whole numbers, and you get the empirical formula as C2H3O. This is the empirical formula in that case. But in the case of ethanol, we cannot divide by 2 because it will give us a 0.5 here, which is not possible. There needs to be whole numbers here. So we divide it by 1 simply and it remains the same. So C2H6O is the empirical formula as well. It is the empirical formula as well. Now lastly, the skeletal formula. Now for the skeletal formula, just know that you don't need to show bonds between carbon and hydrogen, and all the rest of the groups you show, all the bonds between the rest of the groups you show. So we when we did this structural formula, right, we saw there are these two groups, CH3, CH2, and then this OH. Now CH3 and CH2, so this is one carbon atom, this is the other carbon atom. Every point and every joint, they represent one carbon atom. So every point and every joint, they are one carbon atom. Having said that, if you just bond them with an OH group, you get an ethanol. Now when you draw a formula like this, you're assuming that the reader knows that carbon has a valency of 4. It will make a maximum of 4 bonds. So you're assuming that the reader can make the other 3 bonds with hydrogens him or herself. So here you go. You don't need to show these, of course. I'm just saying how a reader should interpret these formulas. Okay. So as you can see, this carbon has 3 bonds. Every point and every joint is a carbon, right? So this is how you draw a skeletal formula, but you don't need to draw these elements, of course. So this is the skeletal formula. Now one thing you need to know is that of course I have told you as well, every point or joint is a carbon, number one, and secondly, all bonds are shown except carbon hydrogen bonds. All bonds shown except carbon hydrogen bonds. Let's be very clear on this stuff. The basics of organic chemistry, right? I hope this is clear. Now since we know how to draw these, I'll give you a compound. Try pausing the video and try doing it, and I'll give you the displayed formula. Try drawing the condensed formula, the empirical formula, the molecular formula, and the skeletal formula. So here we go with the first compound. So here you go. These are your first 2 compounds. Try doing them. Of course, if you've tried them, so let's see how you can actually do these compounds. So first of all, let's start with the most simple, the molecular formula. So let's count the number of carbons. So 1, 2, 3, 4, 5, 6, 7, 8. So C8. Let's count the number of hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 hydrogens, and of course 1, 2, 3 oxygens. Of course we cannot have a simpler form of this formula, so it's the molecular formula is equal to the empirical formula because this cannot be further simplified. Having said that, let's move on to the structural formula. Let's see what the structural formula will be. So before we move on to the structural formula, let's just notice one thing here. I want you to be I want you to be focused here on this uh, portion of this compound. Are you seeing that for this carbon, two CH3 groups are attached to it? You can see it like that, right? So this carbon has a hydrogen attached to it, but it also has two CH3 groups attached to it as well, right? Having said that, then we have a CH2 group, then another CH2 group, then we have a CO group, then we have a CH2 group again, then we have a COOH group. So that is how you'll write the structural formula for this compound. Now that we're done with the structural formula, let's see the skeletal formula. So 1, 2, 3, 4, 5, 6, 7, 7 carbons followed by an OH group, right? So 1, 2, 3, 4, 5, 6, 7. So these are the 7 carbons. You attach an OH group here. With the last carbon, there is a double bond O as well, right? So we have got that covered. So with this third last carbon, we have a double bond O as well, right? Then there's nothing attached to this carbon, nothing to this. There is a CH3 group attached to the second carbon, so we can show it like this. And this will then be your skeletal formula. I hope this is clear. Do rewind the video if you can't get it in the first time, but that is how you'll do it. Alright, now let's go with the second compound. So let's count the number of carbons, hydrogens, and then oxygens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So C10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. H20. And how many oxygens? Only one oxygen. C10H20O. The molecular formula and the skeletal and the condensed formula and the empirical formula are the same once again, right? I hope this is clear. Now let's see how you'll write the structural formula. Now if you notice, with this carbon right here, there is a CH3CH2 group attached here and a CH3CH2 group attached here. So can I write it like 2 CH3CH2 groups attached to a CH, which is attached to a CH2 group here, which is attached to a CH, but the CH is bonded with an OH, right? So you write it in brackets here, followed by a CH. Now you need to show the double bonds. It is bonded with CH as well, followed by a CH3. It is very important that you show the double bonds. It's highly important. Having said that, let's move on to the molecular formula, to the skeletal formula. So 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons in the main chain. 1, 2, 3, 4, 5, 6, 7, 8. With on the third carbon there is a CH3. So a CH3 and a CH2 group like this. On the fifth carbon there is an OH group. So 1, 2, 3, 4, 5. There's an OH group like this. The next two carbons have a double bond between them. Right, so we have a double bond here and a CH3 group attached to that, a CH group of course. So as you can see, this is the molecular so this is the skeletal formula for these compounds. Now for the next two compounds, I'll be only showing you the compounds displayed formula. You need to deduce the structural, the molecular, and the skeletal formula. So try pausing the video and doing them. So here you go with the compounds. So these are your compounds. Again, pause the video, make the molecular formula, the empirical formula, the structural formula, and the skeletal formula for each of these. And now I'll be showing you the answers. So here are your answers. In the comment section below, write down any queries you have regarding these compounds, and I'll try addressing them. As far as the types of formulae are concerned, we've covered all of them in the organic chemistry. Of course, as we go along in our series, we'll be practicing more compounds. We'll have more practice, and then of course we'll learn together. If you have any questions from today's lecture, post them down in the comment section below, and I hope you're enjoying. Take care. Thank you.